Hi everyone. So this is the very first video for Unit 1 and we're working on points, lines, and planes, so section 1.1. So I know it might be a little bit different for you to learn math from a video, but remember this is kind of just your preview of the information, and in class we're going to go back over it to make sure everyone is good and really understands. So we are going to finish the notes that we started in class on the first day of school, so you should have the whole inside part filled out, and that's from the puzzle that we did in class. Okay, so we're going to work on working through some of these definitions and then going over the rest of the examples that we have in our notes. Okay, so when you're watching the videos, make sure that, well, probably not for these, but in general, that you listen to everything that I say and pause the video to work out the problems when you need to, or rewind and go back if you didn't understand something. And then if you really don't understand something after you're all done and you've watched it once, make sure you write down questions that you have on a piece of paper so that way you remember to ask in class. Okay? The whole point of this is so you preview things, but if you don't understand what's going on, it might not be helpful. So you really need to write down those questions so that way I can answer them and go over everything in class so you really understand the math behind everything. Okay? So let's get started. Okay, so we're going to talk about these first definitions. So our first word is undefined term, which I know might sound weird because we're defining what an undefined term is. But in geometry, our undefined terms are three things that they don't have a formal definition, but we can say what they are. These are kind of like our building blocks, so we're not like defining per se what our building blocks are, but we're using them to do everything else. So our three undefined terms are point, line, and plane. So for a point, we can describe it. It's like a location in space, but that's not the formal definition. Okay? So I know the undefined terms sometimes can be confusing, but we don't really have to focus on that. I just want you to know what the three undefined terms are. So our next definition, space, is the set of all points. And that's not a word that we use that often either. And that just means like the set of all points in your problem. So if we were to look at that picture that's on the back, the points that we were given, M, K, N, L, H, and G, those would be the space of this problem. Those are the set of all the points that are shown in this problem. Our next definition is for collinear. And collinear means points that are on the same line. So if we go back to that picture I just showed you, okay, we have lots of different points, and there are two different lines that are shown here. So for them to be collinear, they'd have to be on the same line. So if we look at this line B right here, they show us 3 points on that line. So those points, M, K, and N, are collinear because they all exist on that line B. But G is not collinear because it's over here not touching that line. Okay? So the next one, same idea, but this time we're talking about a plane. So it's points or lines that exist on the same plane. Okay, so if we take a look at that same picture again, we have this plane P, and then we have a line with some points on it, and this other point. So those, point G and that line, are coplanar. But point H is not coplanar because it's on that line that intersects through it instead of being on it. And in class, we're going to make some models for planes like this, and it hopefully will help you see the three-dimensional aspect of this line. The plane part is just like two-dimensional, like a flat sheet of paper, like we talked about in class. But this point, or that line, goes through it and comes out the other side. So it's bringing it to 3 dimensions. So again, those were points or lines that are on the same plane. So we can have points and lines and planes and rays and all those things intersect. So an intersection is a set of points 2 or more figures have in common. So sometimes it might just be one point where they intersect. Sometimes it could be a whole line where they intersect, or even a whole plane. It just depends on what the pictures look like. And we're going to talk more about intersections in chapter 2. We're just previewing that information now. Okay, so let's take a look at our questions at the bottom. So this is just wanting us to kind of analyze those definitions. So it says fill in the blank with always, sometimes, or never. So sometimes with these always, sometimes, or never questions, it helps if you draw a picture to really visualize what's going on, okay? So if you can think of a counterexample or a time it wouldn't be true, then that means that it's not always true, okay? If it happens once but not always, it would be sometimes, and then if it can never happen, it's never, okay? So for question 1, a plane containing 2 points of a line contains the entire line. Okay, so if we have a plane and there's 2 points on that plane of the line, is the whole entire line on that plane? I know that you're thinking, well, it can be drawn like this, but remember the plane goes forever too. So the plane can be stretched out and gets bigger too. So all of the points that are on there, if 2 of them the whole line is going to always be there. And that's because 2 points define a line. So once you have 2 points, you have the whole thing. Okay, so for number 2, it says that line TQ and line QT are blank the same line. So if we have, here's T and here's Q, is that the same as saying QT? Very good. It's always the same line because it doesn't matter which order you put your T and Q. Remember we talked about that? For a line, it doesn't matter which one you say first. If it was talking about a ray, that could be different. Okay, but for a line, it's always the same. So it says, is ray GH the same as ray HG? Are they the same ray? Very good. That one was a never, because remember with rays we have to name them with the initial point first. So if I have ray GH, but then for the second one I say HG, that would be going this way instead of going this way like that one. So that's why they're never the same. They have to have the same initial point, and the initial points go first. So for the next one, it says 2 opposite rays form a line. Very good. That one was always. That's the definition of an opposite ray, is that they are collinear. So if we have one going this way and the opposite ray going that way, they end up making a straight line, as opposed to something like that. You know, if we have a ray here and a ray here, those are not a line. Okay. So a line has endpoints. Very good. I hope you said never. A line can have points on it, but it doesn't end, so it can't have endpoints. If we're talking about a segment on the line, you know, that segment has endpoints, but the line itself goes forever, so no endpoints. And collinear points are blank coplanar. So remember, collinear means that they're on the same line. Coplanar means they're on the same plane. So if they're on the same line, then they have to always be on, well, they don't have to, actually, because we can be talking about different planes. So if we have, these points are collinear, but if we look at a different plane going the other way, and we're going to look at, we'll do a model of that in class. So we're going to go with sometimes on that one, because that's tricky. But it depends on how many planes that they're going to give you, okay? So we'll talk about more of that one in class. So I'm going to put a box around it so we can remember. Okay, so we'll talk about 6 more. So let's take a look at our examples on the back. So we're going to use that picture and just answer the questions about the picture. So for question 1, it says to name the plane plane P in 2 other ways. So remember from your chart inside, and if you don't remember, we can take a look. To name a plane, it says that it's named by 3 points, a capital letter. Okay, so the capital letter is what we already did. We called it plane P because this point, well, it's not a point, from this P down here. So that's one way to name it, plane P. And the other way is to pick 3 points off the plane. So this plane shows us 4 points. It shows us M, K, N, and G. So we can name it a couple different ways. So just pick 3 of those 4 points. So we could say that it's MKG. MKG. Sorry, I just messed it up. Or we could say that it's NKG. Or we could say that it is MNG. So this kind of leads us into question 2. Is MKN an acceptable name for that plane? Good, I hope you said no. And why aren't we allowed to have MKN as a name for our plane? Very good, because those points are collinear. So we can't use those three points on that line to name the plane, because we have actually an infinite amount of planes that can go through that line. And when we make our models in class, it might make more sense to you. So we'll talk more about that one in class too, because sometimes it's hard to visualize the planes going through lines and stuff. But any line can have an infinite amount of planes going through it. Okay, so now it says to name line LK in two other ways. So here's L, here's K. So LK is that plane or line going through the plane. So it's going straight through. So really we just need to focus on this line. Okay, so another way to name it. What do you think? Good, we can use the single capital letter and say that it's line A. Or we can pick two other letters on that plane. So we can say that it's line LH, line KH, and really you could say line KL, but if it's asking to name it in two other ways, I wouldn't just switch the letters. I would try to find other letters that are on that line. Okay, so for number 4, we need to name a pair of opposite rays. So we need to find some rays to begin with. So remember, we have to have a starting point and a direction. So if we looked at M in this way, there's nothing to name from that side. Remember, B is not a point, so we can't use that. So we need to find a point that's in between two other points. So that would have to be K. So we actually have two different sets of opposite rays we can name. We can name the ones that are on the plane, or these ones that go outside of the plane. Okay, so if we're going to use this line right here to name a pair of opposite rays, so we always start with the center point first. So we're going to name ray KN. And what's opposite of KN? Going the other way, we would have KM. So what would be the other set of opposite rays that's in that picture? Very good. So we have KH and KL. So remember, you have to have that initial point first, and then they have to be going in opposite directions. So is ray MN the same as ray MK? So MN, same as MK. Very good. They are the same, and that is because they have the same initial point and the same direction. Okay, so for number 6, it says to name all the segments shown in the diagram. So go ahead and pause your video real quick and try to name all of them. I'll give you a hint, there's 6 of them. Okay, so I hope you paused and tried to name all the segments. Here is a list of all of them that are shown in the picture. Okay, so you may need to pause to check that you have all the ones that are there. I try to do it systematically and like start with one point and go from all the ones that are on that line. Okay, so let's take a look at question 7. Is point P on the plane? Very good. I hope you said no. It's not on the plane. It's, remember, the name of the plane. So we know it's not a point because it doesn't actually have a point with it like G does. Okay, and they usually try to put them like off in the corner too. And another way to tell is that there's no point there. Okay, so number 8, name 3 objects that are on the plane. So this is another one where there can be a ton of answers. Well, not any of those segments, but some of those segments we named, there's different points, there's lines, you can name some opposite rays. Okay, so I'm just going to go through 3 because there's a lot of answers. So first I'm going to say that we just have point G. So point G is on that plane. So one object on that plane is point G. So let's name a line now. So we only have one line. We can name it a bunch of different ways. I'm going to say that it's just line B. We can use any of those segments that we had before. So like segment K, N. I'm going to name 4 things so I get array in there too. So array that's on there, I'm going to use N, M. Okay, so here's how I wrote those things. Okay, but it said any 3 things, so we can just name any of those things that are on there. So an answer that wouldn't be correct would be using point L or point H because those points are not on the plane. Okay, so for number 9, it says to name 3 points that are collinear. So we have the points that are on this line or the points that are on this line. So that would be points M, K, and N. Or we could name the ones from the other line. So L, K, and H. Okay, very good. You guys did your first video. Yay. So I know that this one took a little bit longer, but that's because we kind of went slow through everything. So usually they're about 15 minutes or less. So don't get freaked out yet. Okay, so make sure if you have any questions, you write them down, and then we can talk about them in class. Good job, guys. Werner out.